So to begin the proof of this, we will let n equal 1 and then examine what the statement is. Well, when n is equal to 1, 2 to the 3 times n minus 1, when you evaluate that, you just get 7. And of course, 7 divides 7 trivially. So result is true. The result is true for n equals 1. Okay, so now we want to move on and prove the induction step, having established the base case just there. So we assume the result is true for an integer k. Should be somewhere in the relevant range, k greater than or equal to 1. So i.e., let's just spell out what we're assuming. We're assuming that 7 divides 2 by 2 to the power of 3k minus 1. i.e., let's just spell out what that means. 2 to the 3k minus 1, this is equal to 7 times m for some m. Some integer m. That's what divisibility means. And now what we want to do is consider the next relevant divisee, which will be 2 to the power of 3k plus 1, subtract 1. Okay, now we want for its divisibility by 7. And we want to make use of the induction hypothesis that we've just made, which is this hypothesis here. So I'll expand out this exponent a bit. I'll write that as 2 to the power 3k. It has to be by 2 to the power 3, which is of course 8. I've got my minus 1. I want to factorize it. Well, I'm going to let's attempt to factorize it like this. So I have 8 times 2 to the power 3k minus 1. Okay, that kind of factorization is good because it involves the quantity here, 2 to the power 3k minus 1, that I've made the assumption about. Of course, this equation isn't correct yet, because if I expand this out, you see I get a minus 8 at the end, but I only want a minus 8, so to compensate for that, we're going to have to add on 7. Okay. Okay, I don't need any justification for that. That's just algebraic manipulation. So this now can be rewritten as (8) 2 to the power 3 times my 7 times m plus 7. So that's true by the assumption above. And this is clearly divisible by 7 because this is 7 times 8m plus 7. Okay, so this shows that the assumption that 7 divides 2 to the 3k minus 1 leads to the conclusion (7) divides the next relevant integer, 2 to the power 3 times k plus 1, subtract 1. And this is true for any integer k greater than or equal to 1. We didn't use any property of k that would rule that out. So the last thing I need to finish off this is by the principle of induction. We just really need to invoke the principle of induction at the end to finish this off. We conclude that the result is true for all integers n greater than or equal to 1.